This is Math 2, 10.1 notes. That's Unit 10, Lesson 1. And the title is Quadratic Functions in Standard Form. We're going to be learning quite a few forms this unit for quadratic functions. First one we're going to talk about is standard form. And what does it mean for quadratic to be in standard form? A reminder from our previous unit that a quadratic is a degree 2. So it looks something like this. ax squared plus bx plus c. Now it doesn't have to be a trinomial, but as long as your largest exponent, we call it a degree, as long as your degree is 2, it is a quadratic. Now when it's written like this, all expanded, ax squared plus bx plus c, that's standard form. We're going to talk about vertex form and different forms as we go. For now, this is it. All right, how are they going to look? They're going to look different depending on the problem. Some of them might look like this. Y equals 2/3 x squared minus 5x plus 8. That's standard form. There's your a 2/3, your b is -5, and your c is 8. You might see one like this. F of x is function notation. It's the same as y, equals -3x squared plus 9x. Now this is a binomial. It's still a quadratic because the degree is 2. A is -3. A is a coefficient of x squared. B is 9. B is a coefficient of x. And c, it's not there, but it is technically plus 0. I am going to erase that, but you should know that it is the same thing. A is -3, B is 9, and C is 0. Okay, next one. Instead of f of x, you could call it g of x. It's still function notation. -x squared plus 2. This is also a binomial. And you should know that this is the same thing as -x squared plus 0x plus 2. A is -1. B is the coefficient of x. And since there was no x, B is 0, and C is 2. -1 is A, B is 0, C is 2. You could also have one like this, y equals x squared. Y equals x squared. Okay, and this is a monomial. A is 1, B is 0, there's no B, and C is 0. Again, you can write it like this, ax squared plus 0x plus 0. And I'm going to erase that A because that is 1. A is 1, B is 0 because there's no bx, and C is 0 because there's no constant. All right, what does a parabola look like? Let's talk about just a basic y equals x squared. A basic y equals x squared. We are going to graph these with t-charts, but for now I just want to get vocabulary down so when we graph these in class, we are ready. Okay, parabolas or quadratics, which are also called parabolas, are always going to be U-shaped. When you get to higher level math classes, you'll have restrictions where it's just the right half or just the left half, or it's sideways depending on the problem. Okay, so this is what our quadratics are going to look like. Once we make t-charts and plot the points, they're going to come out to be U-shaped. Okay, some important names. This right here is called the vertex. It's also called the minimum. The vertex of your parabola is either going to be a minimum or a maximum. It's never going to be both. It's going to be one or the other. This is a minimum because it's the lowest point on your parabola. Minimum. Okay, so your vertex is either a min or a max. In this case, it's a minimum. This line right here, it's kind of hard to see because it's on top of your y-axis. That line right there is called the axis of symmetry. Sometimes people will call that AOS. Sometimes people call it the line of symmetry, LOS, or axis of symmetry, AOS. It's the same thing. It's talking about the line where the parabola is reflective. If you were to fold it on that line, it's going to be a mirror image. Okay, so in this particular problem, what is the vertex? The vertex is that ordered pair right there. It would be 0, 0. It's not always going to be at 0, 0. It just depends on the problem. For this one, it is. We're also going to talk about domain and range. What is domain and range? Domain is the set of all x values. The range is the set of all y values. Okay, so for the domain, you're going to read the x-axis. For the range, you're going to read the y-axis. Okay, so let's go left to right. Here's going left, here's going right. Now, right now, my graph is restricted to this little piece of paper, but off to infinity, it's going to get wider and wider forever and ever and ever. It's never going to stop. It's going to get bigger, 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 bigger as it goes off to infinity. So it's going to go leftward forever and rightward forever. We call that all real numbers, which means there's no restrictions. The graph gets wider in both directions forever. Notation that we're going to use from now on, I call it double bar R, but it's just the shorthand notation for all real numbers. You do need to know what that means. Even if you don't write it and you just write it this way, you're going to see that on quizzes and tests. You need to understand the notation. Okay, range. Now the range is not all real numbers because look at the parabola. It doesn't go upward and downward forever. It only goes upward forever. So we're going to use y since y, we're reading the y-axis. The range is a set of all y values. Now y is going upward forever from what y value? 0. So we'd say greater than or equal to 0. And it's greater than or equal to because it's opening upward. It's greater than or equal to because it's opening upward. Okay, so we're going to talk about another one. I'm going to flip this over. We'll call this number 1. Number 2. Y equals negative x squared plus 3. Now, right now, we're not making the t-chart. That we're going to do in class. Right now, I just want to get a general idea of vocabulary. So when we graph them in class, we are ready. Okay, I'm going to have you go up and down, right and left 4. And this graph will go up 1, 2, 3, put a dot, and the graph is opening downward. Again, right now, you don't know why because we haven't made a t-chart. We will do that in class. For now, we're just going to graph it and get vocabulary out of the way. Okay, vertex is same right here. It's that point right there which your parabola grows from, and it's going downward. And it's this point here is 0, 1, 2, 3. So 0, 3 would be the vertex. Now I'm going to flip it back over here. Is this vertex a max or a min? It is a minimum. Now this vertex here, is that a max or a min? It's a maximum. Why is it a maximum? Because it's the highest point on the graph. It goes up, 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 reaches its highest and goes down, 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 down. It never will get higher than that point there. So the vertex in this problem is a maximum. All right, domain and range. Now for us in this class, for now, until we get to further problems where there's word problems, the domain is always going to be all reals, because for us, for now, it doesn't matter if it's opening up or down. Forever and ever, that parabola is going to get wider and wider and wider. It's never going to have a restriction. It's going to go off to right and left forever. So all real numbers. The range. The range is not all real numbers because the graph, remember, range is the y values, the y-axis. The graph is not going up and down forever. It's going downward forever. So we use y for range. Down is less than equal to. Downward from what y value? 1, 2, 3. Less than or equal to 3. And why is it less than or equal to 3? Because it is going downward from 3. I'm just going to put a note here that the vertex is a minimum. Okay, for now, domain is going to be all reals for all of our parabolas. Range, what you should know for the range is it's going to be y is greater than or equal to a number if the parabola is opening upward, and it'll be y is less than or equal to a number if the parabola is opening downward. Do you see that here? Y is greater than or equal to a number, which is 0, because it's opening up from 0. And here, y is less than or equal to a number. Y is less than or equal to 3, because it's opening downward from 3. Okay? Now, another thing you will need to know, we will see this more when we are doing the t-charts. If A is the number in front, if A is positive versus if it is negative. A is this number right here. When it was positive 1, it's opening upward. When it's a negative 1, it's opening downward. So if the leading coefficient, the number in front of the x squared, is positive, it will always open up. And if the leading coefficient in front of the x squared, is negative, it will always be opening down. If it's opening up, it's always going to have a minimum. If it's opening down, it's always going to have a maximum. Now, these are just vocabulary words. We'll discuss more of this in class. We'll actually get t-charts and start to graph. That is it for this lesson.